Hello, and this time we're looking at hypothesis testing with the binomial distribution. I know a lot of people really struggle to get their heads around this. So let's look at this example. We've got this distribution that's been given for us here, b bracket 20 comma p. So that is the number of trials, n, and then p is the probability. And that's what we're testing. The person who originally did this said that the probability was 0.3. We're now coming along and saying, is it? Is it 0.3? And in this case, we're saying that our hypothesis 1 is that it's not 0.3. So we're interested, is it bigger than 0.3? Is it less than 0.3? It could be either, so we're looking at both. That's why it's a two-tailed test. If we'd have said, oh, no, I think that the probability is bigger than 0.3 or less than, if we'd have been specific, it would have been one-tailed. And that's why they're giving half the significance level here. So they're saying 5% significance level, but because it's two-tailed, it's 2.5 either side. In the first part of the question, it's asking us for the critical region for this test. So what we're asked for here is what number of positive outcomes would we expect, or would we, if we got it, so if we got just only one, if we just got one, positive outcome out of 20, would that be low enough that we'd be like, nah, the probability is not 0.3. I think you're wrong there. Or if we got 19, would that be enough to say, well, we've got 19, you reckon it's only 0.3 probability of succeeding, and I've done it 20 times, I've got 19, that's far too many. If you think about how many we would expect if it was, if it came out exactly 0.3, 30% of the time, 20 trials, we just multiply these together, we'd expect an outcome of 6. So, 18, 19 is ludicrous, surely. But is it so ludicrous? Obviously, it's probability. Anything can happen. So is 10 too much? If we got 10, then we'd be like, yeah, that's plausible that, we'd expect 6, but you've been lucky, you got 10. But 12, where's the cutoff? That's exactly what we're trying to find out. What is the critical region? What value, bigger and smaller in this case, is enough that we're like, no, it is wrong. It is not 0.3. It's too many or too few. We're saying no, it is definitely a different probability here. And to work that out, we have to use this significance level. If you remember what the significance level is, it's saying this could happen by random chance. If getting a 10, if there's a 80% chance of that, oh wait, no, that's too big. If there's like a 10% chance that we could get 10 of these happening, 10 out of 20 instead of 6 out of 20. If that would happen with a 10% probability, well then if that happened, it could have been random. There's a 10% chance, fine. We need to find the limit where it's going to be 5% probability or less that these values could come out. And because it's two-tailed, it's 2.5 either side. So if the chance of getting 17 wins out of 20 by random chance, if that's only going to happen 1.3% of the time, 1.3% of the time, if that's only going to happen 1.3% of the time, then that's so unlikely that if it does happen, we'll be like, no, it's not. The chance of that happening randomly is so small, it's more likely that your probability was wrong in the first place. Or the other way around, if it only comes out one time out of 20 and the chance of that happening is 2.3%, again, that's so unlikely to happen that we think that actually you got the probability wrong. Whereas if it comes out, I'm just making these numbers up by the way, 4 times out of 6, and that's got a 3.7% chance of happening, we're like, well, 3.7, not very likely, but it's plausible enough that that could have happened by random chance, and so I have to accept you might be right about your probability being 0.3. So that's what we're trying to do. We're trying to find where are the values on the limit that it becomes from plausible, yeah, that could have happened and still be 0.3 probability, to the point where we're like, no, it's so far out of, it's such a small chance of happening by random chance that I think you're wrong. Okay, that's what we're trying to work out. And that's the critical region. Now we could use our calculator, but we'd be kind of just shooting in the dark slightly for this. So instead, we're going to look for the tables in the either back of your textbook or the formula sheet. And the key things are that we've got that n is 20, we've got the probability is 0.3, and we've got a significance level of 2.5 for each tail. Now what's interesting is that in examples that we looked at in the textbook, it said when it's two-tailed, you round, you go which one is the nearest to 2.5%. Okay, it didn't do that for the one tail, it was a strict cutoff. But in this case, it says you should state the probability of rejection in each tail, which should be less than 2.5%. So this is doing it differently, which is annoying because it's from the same publishers. But this time they are saying, actually, we're going to have it as a cutoff, not go for the one that's nearest. Okay, so those are the things we're going to be looking at. N is 20, probability is 0.3, and we're looking for probabilities less than 2.5. Right, so I need to get my formula sheet up. 1 second. Here it is. This is from the formula sheet. We need an n value of 20, so I'm just going to scroll down a couple of pages. Here it is, n is 20. The probabilities go up in fives. You'll be able to see if it was in front of you on the page. So this is 0. Actually, I'm losing confidence. Yeah, 0.05, 0.1. So we need to count through. So 5, 10, 15, 20, 25, 30. It's this column here. Let's just mark it so we don't forget. So it's this column here. This is our probability of 0.3 that we're testing. We've got 20 trials, and we've got a significance level, if you remember, of 2.5%. And 2.5% in decimal is 0.025. So we're looking for less than 0.025, and you can see that is here. We've got 0.03, so obviously that's too big, and 0.00, and that's too small, so that's great. We've got that value here. So that's in between the 1 and the 2. So 0 and 1 are inside our critical range. 1 is a critical value, and that's part of the critical region. Now remember, when we're doing the ones above, it's much harder. You'd think, well, I'm going to look for values that are 0.0975. But I'm not going to do that at all because these values are up to and including the value of n. So it's a little bit odd. Now, if you remember, the easiest way to do it is to look where the cutoff should be and then go one step lower. So we're looking for 0.975, which you'd expect to be, trying to draw a straight line, you'd expect it to be here in between 9 and 10. So you'd say, 10 is in the critical region. No, it's not, because the probability of 10 and above is not using this value. The probability of 10 and above, if we did that, is 1 minus the 9 value. And if you do 1 minus the 9 value, it comes out as 0.048, and that's too big. That's bigger than 0.025. So it's the one below, and you'll find it's always the case. If you find out where it should be in between the numbers, then you always need to move it. I can't pick it up. You always need to move it one step lower, and then just double check it. So again, let's move this down. Can't find it. There we go. So let's move that down. Let's check it. So the probability of for 11 is going to be 1 minus probability for 10. And if we did 1 minus this value, we would get 0.0 171, I think, if I've done my subtraction in my head right, which is less than 0.025. So we are allowed to have this now. So you can see the critical value in this case is 11. The critical region is anything 11 or more. Just watch out for that bit there. Let's head back to the question and I'll just show you how to write that. Okay, 1 second whilst I flip. Okay, so back at the question, how am I going to write that? It asks for the critical region. Okay, and so we're going to use the value x, and we're going to say x is less than or equal to 1, and we're going to say x is greater than or equal to 11. You have to write it out as two separate inequalities because they're two separate regions. Okay, because we wanted it was that bit and that bit that were the good bits, critical regions. If it had been somewhere, the one bit in the middle, you could have written it as one inequality. But if you've got two separate sections, two separate regions, two separate inequalities, please. Right, and then it says you should state the probability of rejection in each tail, which should be less than 2.5. So you just write down whatever the probability was for each of these things. So literally write down the entry for one, and for this one, the probability of 1 minus the probability of 10. Okay, so write those down. I'm not going to go back and get those. I'll let you do that. So in part B, it says state the actual significance level of this test. So for this, we've actually already got it. If you in part 3A, if you did write those two probabilities down, remember 2.5% was in between, and we went for the one that's below, and in this case we went for the one that's above, so that we were within that 2.5. And then the actual significance level is just adding those two probabilities together. Because if those are the limits, if we're not allowing, if we're saying it has to be 0, 1, or 11 or more, then the probability that you're in those sections is just adding those probabilities together. And that's literally what you do for 1 mark. That's what you got to do. So the actual value of x is obtained as 3. So they've done the experiment 20 times, and they've got a value of 3. State a conclusion that can be drawn based on the value, giving a reason for your answer. So the question always is it in the critical region? If it's in the critical region, then what you're going to do is you're going to say there is enough evidence to reject the null hypothesis, and you would carry on with whatever you're going to do. So you have proved your point, and not that you can say H1 has been proved, but you have rejected H0 and you move on with life. You keep investigating, whereas the other way around, if your value is not in the critical region, then you have not enough evidence to disprove it. So H0, the null hypothesis, wins because it's saying, well, I'm not confident enough to say that you're wrong and H0 is wrong because it could come out that way. I could get a value of 3 and this still be the case. In this case, you say there is insufficient evidence to reject H0. You should always write it in terms of whether you can or can't reject the null hypothesis rather than saying I'm going to accept something else. It's just can you or can you not reject. So for 2 marks, I'm imagining that there's a mark for saying whether 3 is or is not in the critical region, which looking at this, it should be pretty obvious whether it is or isn't. And once you know if it is or isn't, you're then going to have a second mark for saying either, therefore there is enough evidence to reject the null hypothesis, or you would write, therefore there is insufficient evidence to reject the null hypothesis. And I'm not going to tell you which one it is because it should be pretty obvious for you looking at 3 and the critical regions. If you're struggling with that still, then you can leave a comment below and we'll let you know which one it should have been and why, but I'm pretty sure you'll find that relatively easy. I'll go through another question, which is on the same topic. Another question I was asked to go through. It's question 6 from this sheet, and it says it is known from past records that 1 in 5 bowls produced in pottery have minor defects. Now, that instantly to me is a probability. 1 in 5 bowls from past records, that is definitely a probability there. So let's just move the pen again, and we can write that down as the probability as 0.2. That's 1 in 5. For monitor production, a random sample of 25 bowls was taken. So that's the sample, that's n, isn't it? That's the number of trials. You trialed 25 bowls, and the number of such bowls with defects was recorded, and that'll be the x value. Using a 5% level of significance, find critical regions for a two-tailed test. So it tells us it's a two-tailed test. If it had said, work out whether this is true, then that would be two-tailed, because you're saying, is 0.2 right? Because it could be more minor defects or fewer. If it had said, what's the, find the critical region, if there are more defects than 1 in 5 bowls, then obviously that will be one-tailed, or it could have said fewer there. But anyway, it told us it was two-tailed, so we just go straight into that. Two tails, find critical regions for a two-tailed test of the hypothesis that that's the case. So I should have said here the probability, I should have said that was H0. The H0, that was supposed to be a colon, it's come out as an exclamation mark, so never mind. So H0 is that's the probability, and H1 is that again, that's a colon, not an exclamation mark, is that the probability is not equal to 0.2, and that was supposed to be an equal sign with a line through, but it's not easy to do with the mouse. Okay, what we're doing again, find the critical regions, and the probability of rejection in either tail should be no more than 2.5. So just like the question we just did, they're saying it's two-tailed and that we are cutting it off. We're saying it has to be less than 2.5. We're not doing the rounding thing that it did in the textbook, which begs the question, why did they do it like that in the textbook? But let's not get into that. So we have the values here, and we're looking for the critical region. If you're looking for the critical region, then it's easier to use the tables. If we were doing it on the calculator, we'd have to try 0, try 1, try 2 until we found the boundary. So it's much easier to do it from the tables this way. If they tell us what the probability is, then it's much easier to if they tell us we've got an amount and ask us to, 7 bowls had minor defects, does that confirm or deny, rather than asking for what the critical values are, then we could use the calculator and compare the percentages. But this way around, it's much easier to use the table. So 0.2, n is 25, and we've got 2.5% to look at. So let's go to the tables here, and here we've got n is 25. We've got the probabilities coming across here, so we've got the 0.2, that's what we want, and we want 0.025. So unfortunately this one, 0.027, that's not enough, is it? 0.027 is slightly too big, so the critical the critical value is 0. If we got 1, we'd be like, well, could still be the case, just acceptable. And this is different from what it would have been in the textbook. In the textbook, it would have said, well, that's the closest. But in the question there, correct me if I'm wrong, but I understood that as meaning it's a cutoff. So 0 is our critical value here. And then as we come down, we can see it's maxing out here, so that's fine. We can look through. Where does it give us 0.975 would be here, but remember that's not the answer. It's always one step lower than that, so move the line one step lower. And again, let's check it. Okay, so if we're saying its probability of 10 or more, yes, or the critical value should be 10 or more, then the probability of 10 or more is 1 minus the probability of x is less than or equal to 9. And this is the value that's equal to 9, and that's 0.0173, which is okay. If I said, oh, what if it was 9? What if I was right the first time and the cutoff should have been here? It would have been 1 minus 0.9532, and that's going to give me 0.04, which is too big. So I'm right to have the cutoff here, because 1 minus the 9 is within the limits, and that's the probability for 10 or more. So critical region is 0 and 10 or more. Let's go back to question. Bear with 1 second. Oh, okay, so we're back to the question. It said find the critical regions. So just like before, we're just going to write two inequalities. X has to, well, you could say equal for the lower boundary, or you could say is less than or equal to 0. I mean, and then x is greater than or equal to 10. State the actual significance level, just like in question 3, whatever those two probabilities are, can't remember what they were, but go and get them again, add them together. That one is tick. At a later date, a random sample of 20 bowls was taken, and 2 of them were found to have minor defects. Test at a level of 10% significance whether or not there is evidence the proportion of bowls with minor defects has decreased. So everything has changed. This is a brand new question, and the fact that it's told us it's decreased means that we've got a one-tailed test here. Okay, we're putting all that 10% on it being lower. So this time n is reduced to 20 bowls. 2 of them are found to have defects, so that is x equals 2. The probability that we're testing is, I presume, still 0.2. It hasn't said anything different, so we're still using that. And we've got a 10% significance level. That's what we're testing to. So if I now work out what is the probability that I get for 2 bowls out of 20, and if that is less than 10%, then I can reject H0. So again, state your hypotheses carefully or clearly. So H0 is that that's the case, and H1, the probability is decreased, is that the probability is less than 0.2. So if we get a probability of less than 10% on this, then we know that that we could, less than 10% in the critical region, we're going to go for H1 instead. We're going to reject the null hypothesis. And if we get something bigger than 10%, then we're going to accept the null hypothesis. I'm going to do this on my calculator. You could look up the table, change it to n equals 20, go down to x is 2 and read it across. In fact, we might do that as well. But let's bring up the calculator. And we're going to go back to this. We don't want this one. We want the CD. So we're going to go menu 7. We want the cumulative distribution and a variable. I'm going to type in the values that we've got. So x is going to be 2, n is 20, and we're testing 0.2 as the probability. And the chance of this happening by just random chance is 20.6%. And we've got a 10% significance level, so that's 20% is not, small enough. It's not small enough to convince me that has gone down. So what I'm going to say here is I'm going to say, I'll obviously write it down. I'll say the probability of all of this happening for 2 at that probability of 0.2, the chance of that happening is 20.6%. So there is insufficient evidence to reject the null hypothesis H0. Now, I appreciate that these questions aren't particularly easy to think about. We talk about probabilities of the thing happening, and then the significance level is also a probability, and it's a negative as well. It's sort of saying I reject this because I haven't got a good chance of it happening, and it feels a bit weird. So do take your time, make sure that you're understanding which way the numbers are, which way you want the numbers to be. If you're at all uncertain, just leave me a comment and I'll try and explain it in a different or better way. But I'll leave it there for now, let you process that, have another go at the questions, see if you get them right this time, see if you're confident with them, and let me know if you're not, and we'll try and explain it again. Thanks very much, and see you next time.